So this lesson's about maximum and minimums of functions. Some people call those extrema. And that's kind of a strange word, but that word extrema just means a highest value or a lowest value. And of course, a max would be the highest value and a min would be the lowest value. And there are two ways to describe extrema. You have absolute, which are the highest of the highs, and you have relative, which is just a high point but not the highest of all the highs. So this would maybe be like any other high point. And of course you could also say the same for an absolute min, or relative min would be the absolute min would be the lowest of all the lows, and the relative min would be just any other low point. So extrema, or maxes and mins, whether they're absolute or relative, that doesn't matter necessarily as to where they happen. And they always happen at these values called critical numbers. And here is how you find those critical numbers. So what is a critical number? Okay, critical numbers are basically where maxes or mins occur most of the time. If you have a max or a min, it will occur at a critical number, but just because you have a critical number, that doesn't necessarily mean you'll have a max or a min. I'll explain that in later videos, but basically critical numbers are where the derivative is 0, and that would indicate that you have a horizontal tangent. Like if you had a max, here the derivative is positive, here the derivative is negative. Remember, derivative is a slope. And up here where you have your max, the derivative is 0, or constant. So maxes or min could occur where the derivative is 0. Maxes or mins could also occur when the derivative is undefined. Remember, undefined, there's certain places where you can't take a derivative, such as maybe a sharp turn. And so here a derivative is negative, here a derivative is positive, but right here you do have a min, it's just that you can't take the derivative there. So that's why this min wouldn't show up under case 1. Okay, so you basically just check both of these, and then also anytime you have an end of an interval, you have to check. So maybe I have a function that looks like this. Okay, so this is an absolute max, and here is just a relative max. And this would be a relative min, and this would be my absolute min. And these are only absolute, you only count these because they're closed intervals. If this was an open interval, I would not have an absolute min, only a relative min. So keep that in mind. So these three places are where a critical number occurs. So let me show you an example of that. So here we have a function. This is clearly quadratic, which means it looks like a parabola. So this is going to be U-shaped. So we know ahead of time this is going to have only one max or min. It has no endpoints as of yet because I didn't give you a specified interval, so we don't have to check any endpoints. But we do know this is going to point upward because we have a 3 positive leading coefficient. If we didn't know any of that, we could still find the min, though. What you do is you take your derivative, which is 6x minus 4, and you set that derivative equal to 0. So x equals 2/3. And this is a critical number, so this is going to go on our critical number list. So x equals 2/3, and we'll find a y value for that. In other words, find the rest of the ordered pair. Okay, so we check step 1. Step 2, where's the derivative undefined? So I'm looking at this derivative right here, and I see that this derivative is never undefined. This is just a polynomial. I can put anything in for x. If I had a derivative that looked like this, maybe, then my derivative would be undefined at -2. So I would have to add that to my critical number list. And my derivative would equal 0 at 3. And I would have to put that on my list. So it just depends on what your derivative is. You check the derivative for 0 or undefined, And here I said already that I don't have any endpoints. If I did give a specified interval, like maybe this question said on the interval from 0 to 4, and these were closed, then I would also check these both of those endpoints. See how the endpoints are on my list of where a critical number could happen? Critical numbers happen where the derivative is 0 or undefined, which is not in this list, and also the endpoints. So all I have to do is find these three y values, and then I can look for the highest and lowest y values. So for instance, when x is 2/3, I'll stick a 2/3 back into here. You can see here that I've put in a 2/3 into here and here, and I worked all that out and got 14/3 here. So at 2/3, the y value is 14/3, which is about, what, 4 2/3. When x is 0, I'll put a 0 in here and here and get 3 times 0 minus 4 times 0 plus 6, so that y value is a 6. So this one is clearly higher than this one. If I put a 4 in here, you can see that I would get a 38. And just by looking at these three y values right here, I can tell what the maxes and mins are. So the minimum happens right here, and I have a max here and a max here. And this one's the absolute max, this is a relative max, and this is my absolute min. If I drew a picture of this graph, my picture would look like this. So at x equals, this would be the ordered pair 2/3, 14/3, and that's indicated right here. And this would be 0, 6, and this would be 4/38. And you can see I have an absolute max here, a relative max here, and an absolute min here. And that's all about critical numbers.